Hello. Okay, hello everyone. This is I'm going to be walking you through my exploratory data analysis approach of the project Amazon Prime TV and movie trends. So, this is an individual project that uses data sets containing information like title, type, genre, IMDb score, release year, and more. The aim of this project is to discover trends and generate insights that help drive better content decisions for platforms like Amazon Prime. Now, coming to the project summary, in this project, I have performed in-depth analysis using Python libraries like Pandas, NumPy, Matplot library, and Seaborn. And my approach included cleaning and preprocessing the data, visualizing the patterns, understanding user preferences, and based on ratings, runtime, IMDb scores, etc. And also finally proposing business recommendation based on the findings. So the data set did not have many missing values, but I still checked for nulls and handled them properly. So this analysis was conducted individually using the Python libraries such as Pandas, NumPy, Platinum, Matplot library, Seaborn, Plotly for data and cleaning, manipulation, and visualization, as I told. And the main objective was to derive meaningful business insights that can guide Amazon Prime in its content creation, recommendation strategies, and also user engagement improvements. So, first of all, the project began with the data loading, initial exploration, identifying missing values, incorrect data types, anomalies, etc. And a thorough data cleaning process was performed, which include handling null values, converting data types, standardizing common values. This helped to prepare the data for deeper analysis. Now, next, univariate and bivariate visualizations were used to explore individual columns and relationships between them. For instance, like charts were created to analyze the number of movies. You will see it coming later. Like I have prepared different charts to show which show is more like how many seasons how many series with these many number of seasons have more user engagement, which like movies or TV shows have more user engagement, then which type of genre is more like people watch it more, etc., etc. Like there are different types of charts that I've prepared, so you can see that coming forward. And then this visualization helped to highlight some important insights. I'll be also sharing that, showing the positive and negative insights of these charts. And then I had also created a correlation heat map that is used to identify numerical relationships between variables such as IMDb scores, number of votes, seasons, noun times, and a pair plot is also created used to further explore multivariable relationships, which added depth to the interpretation of the numerical fields. So then also I'll be saying about the solution to the business objective, and that's all. Now let's get into the project. This is the GitHub link that I've done. I've also provided my GitHub link. Now the problem statement. So the problem I'm addressing here is how can we identify what kind of content performs best on Amazon Prime and what improvements or trends can be used to boost user engagement. The business objective is used to use this analysis to make a strategic decision about what type of content to promote, produce, or acquire in the field. So basically, after like performing these charts, you will see like what type of content should be promoted, or what kind of content should be produced more, acquired, etc. on the OTT platforms. One second, let me see if audio. Yeah. Okay, now this is the business objective. So the main objective of the Exploratory EDA project is to extract meaningful insights from Amazon Prime's TV shows and movies datasets to support better decision making and enhance business outcomes. By analyzing key attributes like content type, genre, release year, runtime, IMDb ratings, popularity, the project seeks to uncover trends and patterns that reflect viewer behavior and content performance. So the specific goals are to understand the content distribution, identify viewer preferences, track popularity trends, support data-driven personalization, and assess strategic planning. So ultimately, this analysis enables us to Amazon Prime to make informed data driven decisions that improve user experience driven drive data content success and strengthen its position in the competitive OTT trends or market. So these were the general guidelines that is to be followed while making this EDA. That is, I think I followed everything. And then coming to the data. Now let's begin. Here, to know your data. So first we have to import the libraries. I've imported Pandas, NumPy platform, Matplot library, Seaborn, Plotly, etc. And now coming to the data set loading. We have to load the data set. And after loading the data set, this is the first view of the data set. Now we can see the number of rows and columns count in the data sets of titles and credits. These are the number of rows and columns in titles and credits. Yeah. This is the data set information. After seeing the columns, we can see what all types of columns are present in each of the data sets, that is titles and credits. This is the titles data set. Here, there's ID, title, type, description, release year, age, certification, runtime, production countries, IMDb ID, scores, vote, etc. And then in the credits, we can see person ID, name, character, role. These are the duplicate values. Duplicate rows in titles were 3 and duplicate rows in credits were 56. So here, so to remove, then we run a code. We run this code to remove them, and the duplicate rows were removed. Then missing values and null values. We run this code to see the missing values and null values. Then yeah. Now understanding your variables. So what all types of variables are present in our data sets can be seen by running this code. That is, in titles, we can see there's ID, title, type. As we seen before also, we see the same thing here. And then to describe the titles and this thing. Sorry, this was supposed to be here. Yeah. Then check unique values for each variable. By running this code, we can check how many types of unique values are there for each variables. Then this is the data wrangling code. Here we can see null values after wrangling. These are the null values after wrangling. Now, what all manipulations have you done and insights you have found? So initial insights where the data contains more movies than TV shows. Most content were released after 2010. Unknown or missing age rates are quite frequent, which could affect age-based analysis. IMDb scores are mostly between 5 and this thing. And then we removed rows with missing title values since they are essential for analysis. Filled missing values in IMDb score and runtime with their respective column averages. Removed duplicate rows to ensure clean and consistent data. Reset the index after cleaning the proper to maintain the proper raw order. So now let's get into the charts. So I've done total 15 charts that included correlation heat map and pair plot. I've used line plots, I've used box plots, I've used bar plots, count plots, etc. You will be seeing it further. Now coming to the first chart I did, here it's the count of movies versus TV shows. It shows how many uh, which is more, like movies or TV shows are more in the Amazon Prime platform. So I've used a bar plot to see which is the this thing. Sorry, not bar plot, count plot, and we see that movies are more in Amazon Prime, and the yeah. Why I chose this chart is that it's best to compare the count of categorical variables like type, movies or TV shows. A count chart, sorry, makes the comparison clear and visually easy to understand. And positive insights gained from this chart was that platform appears to be movie dominant, which can attract users looking for a quick standalone content. This aligns well with binge watching behaviors and casual viewers. Negative insights are the lower the number of TV shows could be a missed opportunities, especially since long format content increases viewer attention. Amazon may consider investing in more series based content to balance offering. Coming to the chart 2, In this chart, I've used count plot again to see the distribution by age certification. Here we can see in this chart the unknown is more high, and then R, then PG-13. Here TV, like family shows, and the content for like sorry, the viewers, that is of family subscribers, are very less in this chart. So you can see that family subscribers are less in Amazon Prime. So to promote them, we can like increase the content, like because higher this thing in the in the chart we can see unknown is the highest. We can include more, like we can show what all movies or TV shows in like has these many age preferences, so people from that age preferences can watch it. So we used a count chart again because we are analyzing categorical variable age certification. So count chart helps to compare the volume of content across different age ratings easily and visually. Now, coming to what are the insights and found from the chart, a significant portion of the content was unknown age certification. Among the label, 116 plus and 18 plus have highest content volume, and the content for children and family is relatively low. So, the negative insights with the higher number of unknown certifications might reduce trust among the parents or cautious viewers. Also, limited content for children could mean losing out on family subscribers, as I told. And the positive insights where the platform caters more towards teen and adult audiences, which makes a global OTT trend for mature and more drama driven content. Coming to chart 13, here we can see that here we are in this chart we'll see the number of titles released per year, and here I've used the line chart to clearly visualize the number of titles released over the years, and it helps to understand the trend in Amazon Prime's content growth or decline. And the chart shows the content released increased significantly after a certain year, example post 2015, possibly reflecting on Amazon's strategic push into original content. There may be also certain noticeable dips in certain years, like during the pandemic. See, here you can see there's a dip. Positive insights where the growth over time indicates Amazon is expanding its catalog, potentially increasing user engagement and subscription values. And negative insights were that if there is a sharp drop in recent years, it may hint the reduced production or acquisition. One second. Yeah. Now, chart 4. In chart 4, we are seeing the top most common genres. And here I've used a horizontal bar chart, and in this chart you can see drama has the most common, is most common. Comedy is next in line, then thriller, then action, romance, crime, horror, all those things are last. So here the positive insight says the platform is targeting emotionally engaging and mainstream genres like drama and comedy, which have a broad audience appeal. And also, the negative insight is that less content in niche genres like science fiction or fantasy could make Amazon Prime less attractive to fans, those categories, compared to competitors like Netflix or Hotstar. Now, chart 5. In chart 5 is in the distribution of IMDb scores. The IMDb score of 6 is the highest. And I used a histogram with a KDE curve to visualize the distribution of IMDb score. It helps to show where the most content falls in terms of viewer ratings and how spread out or skewed the ratings are. And most titles have IMDb scores of 5 to 6, 5 to 7. And positive insights are the majority of the content is above average in ratings, which helps maintain audiences' trust and satisfaction. So, and lack of top rated content could mean the platform needs more critically acclaimed or award winning titles to stand out. Chart 6. In chart 6, IMDb score over time is done, and here I've used a line plot showing rating stability could mean consistent quality but not necessarily breakthrough hits. So here we can see IMDb scores are generally clustered between 5 to 7 over the years. Some rated Some high rated contents appears more 2015 showing quality investment in recent years. And the positive insights of the steady IMDb scores over time show consistent quality. The appearance of high rated titles in recent years is a strong signal of content improvement and better audience reception. The negative insights if score distribution remains too average, 5 to 6 range, it might suggest a lack of standout and truly critically acclaimed content. Coming to chart 7. In chart 7, here we can see top 10 movies by runtime. 9 hours is the first one, Millennium is second, and then like that, last 1900 is the last. So here we can see that it clearly displays and compares the top 10 titles with longest runtime, making it easier to interpret the larger numerical differences. So positive insight is that yes, understanding runtime extremes helps our platform recommend content-based user watch time behavior, and however extremely long runtimes might also lead to viewer drop, which could be a negative impact. Now coming to top 10 directors on Amazon Prime. This is chart number 8, and I've seen. So here we can see Joseph Kane is the top 10 directors. He's coming first, then Sam Newfield, Jay Chapman, etc. So here we can see the top 10 directors. It helps us to compare top 10 directors without overlapping the text. Like that is why I've given a horizontal. You can see in the X line. And then here the positive insight is that helps Amazon Prime identify which director drive the most content and possible user engagement, and over reliance on fewer director might lead to lack of diversity in content style. Now coming to chart 9. In chart 9 we can see distribution of runtime by genre. I've used a box plot to see this, so we can it shows effectively the median quartiles, potential outliers for the runtime within each genre. This helps us to understand typical runtime range for content in various genres and compares these distribution, which is valuable for content planning. These are the insights that I found from the chart, and also the positive and negative impact. Chart 10. Chart 10 is top 10 production countries by average TMDB score. So here we can see Dominic Republic and Singapore has the top is the top production countries, and the least is Japan, Costa Rica, and also Palestine. So positive is high scoring countries like Singapore and Dominic Republic can be promoted more, and low average scores either mismatch, either improve content curation from those regions. Now coming to chart level. Here you can see I've given a scale for drama blue, comedy orange, romance green, action red, thriller. So here we can see drama is the most. Yes? Yeah. So the insights is certain genres show consistent growth. Some genres may have spiked in certain years and like it goes down in certain years, and then decline in certain genres. Positive insight is the chart helps to identify which genres are gaining popularity over time, and negative insight shows a decline. Genre showing a decline may reflect changing viewer preferences or content fatigue, which can lead to reduced engagement if not addressed. Chart 12. In this we can see top 10 countries by content availability on Amazon Prime. Here US is first, then India, then like that it comes. Last one is Italy, I think. Yeah. These are the insights, and these are the negative, positive, and negative insight. Coming to chart 13, here it shows average IMDb scores by number of seasons. These are number of seasons, and we can see the less the number of seasons, the more people watch it, and the more the seasons, people watch it less. You know. Yeah, so this chart shows whether long running shows tend to be rated or whether short limited shows are more critically acclaimed. Shorter series tend to receive better ratings, suggesting that the viewer may prefer conscious and well crafted storylines over longer ones. Positive and negative is that negative is that lack of clear differentiation might make it harder to predict success based on solely on the number of seasons. Now coming to chart 14, that is a correlation heat map. This is the correlation heat map, and you can see why did you pick a specific chart. A correlation heat map gives a quick overview. You see, it highlights that IMDb scores correlate slightly with popularity and votes, useful for predicting performance. That is the insights that is found. And here it shows a relationship between numerical values. Sorry, numerical values like IMDb score, runtime, popularity, TMD, etc. Then insights from the chart is that IMDb score and TMD score show a strong positive correlation, suggesting that if one is high, the other tends to be high too. IMDb scores are moderately correlated with popularity, meaning titles with more votes have higher popularity. This is a pair plot. The chart 15. This is the last chart and it's a pair plot. Pair plot allows us to visualize relationships across multiple variables like runtime, score, popularity all at once. Yeah. So the insights found from the chart where the titles with more votes tend to have moderately higher scores, but it is not strong linear relationship, meaning vote count does not always mean quality. As popularity increases, IMDb scores also tend to increase. This shows a popular titles attract more user engagement. Now, last solution to business objective. So, based on the EDA, here are the potential solutions and insights related to business objectives. That is, objective one, understand the content distribution. Objective 2 and 3 is that identify viewer preferences and track popularity trends. Objective 4 is support data driven personalization. Objective 5 is assist strategic planning. So, based on the insights, we can see that Amazon Prime should continue investing in drama and comedy, but also explore genres like documentary, thriller, science fiction that show potential. And high quality, shorter TV shows with 1 or 2 seasons have better ratings. So, limited series can be a great investment. Targeted age based recommendation could enhance user satisfaction as a large portion of content is rated 18 plus. Investing more in high performing production regions and top rated directors can also improve platform content quality. So, yeah, um, this is the same. Like what I've given here, we can what do you suggest the client to achieve? So we are doing this for an Amazon Prime platform, and I suggest the platform to optimize genre focus. That is by identifying high performing genres like that is drama and comedy with strong IMDb scores. The platform can prioritize these genres with future acquisition of production. Then time based release strategies. That is um, what analysis of yearly trends shows a steady rise in content. Like you have to see what is the trend, and according to that you have to release some movies or TV shows, and then that will gain more views, you get me. And then coming to the focus on highly rated directors, like if you produce or if you promote or produce or acquire a movie or a TV show that is by the top 10 directors, like in this chart we saw Joseph Kane and also Newfield. So by promoting their movies or producing their movies, there will be a more user engagement. Then so these are the strategies that is to be applied. So by this we can see maximize viewership, retain more users, and ensure a data informed roadmap. Now, conclusion is that in this exploratory data analysis project on Amazon Prime content, we analyze various aspects such as content type distribution, age certification, genre trends, IMDb ratings, director performance, and more. Using 15 different visualization charts, we identify patterns in user ratings, release trends, content quality, directors, top 10 directors, top most content, all those things. And the insights gained help us recommend genre optimization, better content promotion, and improved recommendation systems. Overall, this analysis supports data-driven decisions making for Amazon Prime to enhance content strategy, increase viewership, and boost customer satisfaction. So, yeah. So this project helped me to understand how data can be used to support business decisions in the entertainment industry. So thank you for watching my video, and I hope I did well. This is my first time, so I hope I did well. Okay. Thank you.